Hi everyone, my name is Patrick. I'm currently HR person at Python Italy, and I currently live in London, and I'm interested in both backend and frontend. I've been using Django for about 10 years now and doing frontend for about more or less the same time. And you can find me as Patrick91 online if you want to tweet me or if you have any question. Today I'm going to talk about a technology that I've been using over the past 2 years, I think, more or less. And one of the reasons why I try to experiment with technology is because I really want to improve my workflow. I want to try to find new technology that can speed up my developer experience and also improve the user experience for the user of the apps I build or the website I do. So before digging into what GraphQL is, I'm going to do like a small digression on how the web used to be and what the web is now. So it used to be like something like a simple collection of documents where you had a single server and you had like a list of documents where the user could navigate between them using links. And usually these documents were just HTML, CSS, and maybe some JavaScript for like some animations. But over time, the web has changed, as we all know, and the other requirements have changed as well. So for example, we could have something like different data sources and one single backend that would handle this data and then send the data to all these clients that we can have, like smartwatches, phones, desktop devices, and even fridges in like these days. So one of the ways we used to communicate between a client and a backend, we used to use APIs, and more specifically using REST APIs. If you're not familiar with REST API, it basically says that your API is a collection of resources, and each resource has its own endpoint, and you would do it would use HTTP verbs to do operation on those resources, like get, post, delete, and patch. The problem is that REST is not perfect. It's not a standard as well, so everyone is doing it a little bit differently. And one of the issues that I usually had is that you have to do too many API calls if you not fetch data. So let's suppose that we have this simple API that's returning a user data. So let's say that returns a user with their name, a list of friends, and avatar. This is nice. We're using links so we can fetch data for all the other users. The problem is, if I'm building an application where I need to show all this data in one single screen, I need to do an additional 2 requests in this case. So one request for each user. And this is a waste of bandwidth for the user, and also it's not easy to implement in the front end. So one solution would be to create another endpoint where you can do user with friends, and then you get something like this, where you have the friends expanded. The problem is that you might need also the images of those users in another application, so you might end up doing more and more endpoints for all your different use cases, especially if you want to do, for example, a light version of your application. And this, over time, it gets really, really big. And for example, Coursera at some point had like 1,000 different REST endpoints that they had to maintain a document. And I think we can, if we can reduce this number of endpoints that we have to document this better. Another issue is that we have too much data when we send information to the client. So for example, instead of building the API with different endpoints, we could send just one single API where you return all the data that's possible to have. The problem with this one is that if I'm building a screen that only needs, for example, the username, we're basically wasting bandwidth and CPU resources because we're sending data that's not needed to the client. So can we do better? We could extend REST. The problem, as I said, is not a standard, so everyone is doing things differently, which means that we need to document all the extension that we build. For example, we could do, I don't know, get parameter to expand some fields. We can use headers to say, oh, this is a client, mobile client, so send images that are smaller, and so on. So for some of these reasons, GraphQL was created. GraphQL solves some of those issues quite in a very nice way. GraphQL was created by Facebook in about 2012, and it's been open sourced in 2015. So it's been used in production for a bit, and also it's been used by loads of companies. They say like Twitter, GitHub, Coursera, and so on. So GraphQL is a specification, and it's defined as a query language for the APIs. That means that basically we can send a document to our GraphQL API, and then we get back a result. So basically, it's the client that is in charge of saying what the data is needed for their application. A difference with REST APIs is that you only have one single HTTP endpoint, which usually is /GraphQL, and you would send a POST request with a document saying, oh, this is the data I need. And a document will look something more or less like this. So in this case, we are saying, oh, I need the user, their name, their email, and their list of friends with their name. And when we send this request, if we have data on the backend, we get something like this back, which is basically what we asked for. If we change the document, we basically are changing the response as well. Another interesting thing of GraphQL is that you have types. So every field in your API is typed. You have two different types. One is scalars, which are basically like base types, like integer, float, string, and so on. You can also define custom types if you need to define like date, time, and so on. And then you have object types, which are basically a collection of types. So you have different fields where you can either have another scalar type or another object type. For example, in our previous API, we can have a type of user. They have name, an email, and a list of friends. And then you have a type of friend, which only has a name. Another cool thing, I think, is the introspection. So every GraphQL API, by default, returns the schema. So basically, you can get all the fields that you have on in this API. And this allows to use tools like GraphiQL to basically introspect the API without actually having to read the code or remember everything. And I'm going to show you a quick demo of this later. But for example, in this case, we are getting the information about this API without having to read the documentation. So I only shown you how to do queries. Of course, we want to do multiple operations. And in GraphQL, you have three main operations, which are query, mutations, and subscription. Queries allow you to get data from the backend. Mutation allows you to do any operation with side effects, like creating data or sending emails. And then you have subscription, which allows you to subscribe to events on the server, for example, when something changes. This is a document that you send to do a query. And since query is like it's a common operation, this is like the short version of doing a query. The actual syntax looks like this, which basically you have the first token is the operation type. Then there is a operation name, which is basically used only for debugging. Then you can have parameters. And something interesting of GraphQL is also that you can have parameters for like nested fields. So for example, in this case, you can limit the number of friends in the response. And then same for mutation. You have the type, name of the operation, and optional parameters. And substitution works the same. So syntax is quite simple and easy to use. So this is really nice. We can use it with Python using this library called Graphene Python. And I think it's the only library available so far for GraphQL. It's easy to install, just to pip install Graphene. And then to create a small hello world, you can create a class called query where you define the fields. And in this case, we're just defining hello field, which is returning a string in this case. And then you need to specify the resolver function. Resolver functions are basically the methods that are being called when you request a field. So in this case, when we request the hello field, the resolve hello is going to be called with, and it's going to return only hi DjangoCon for now. And also, you can execute them directly, but usually you would have like a Django view or like a HTTP call to execute this schema instead of executing directly. And yes, there is also an extension for Django. This allows to use all the Django features like forms, models, and so on. It's easy to install. You need to add to the installer app so you can use the views, and then you need to specify the path to the schema. So the Django view is able to fetch the schema. You add the view to the path, to the URLs, and you can also enable the IDE graphical. And then it's quite easy. You can basically use the models to create the GraphQL types without typing again all the fields that you have. And then in the resolver function, you can just return a query set, which is basically going to be converted by Graphene to GraphQL types. That was quite quick. Let's create a simple API, and this is based on the Django pools application, more or less. Let's say that we have two models. One is pool, which is only a question, and then there is a choice, which is linked to a pool. It's got a choice text and a number of words. So the first thing we want to do is to create the object types, which are basically the types for GraphQL. Those types are going to be shown in your API. So using Django object type, it's quite easy to create those types because it's basically up to this base class to create all the fields that are needed for the models. You can also extend additional fields and additional resolvers if you need to. Then the first query we can do is to list all the pools, and it's the document that we can send to the backend to fetch all the pools will look something like this. So we fetch the field called pool, then we fetch the question for this pool, and then the choice set. And in Python, will look something like this. So we have a query, and the field is a list of pool types, and then there is a resolver function that's returning all the pools from the database. Then we can do a query for a single post. As I said, in GraphQL, we can pass arguments to each field. So in this case, for example, we want to fetch the pool with ID ABC, and we can do it like this. And the rest is similar to the previous one. The only difference is that the field name is pool singular and accept an argument. In Python, it looks like this. We define a graphene field, and then we pass the list of arguments. In this case, just ID, which is a type of graphene.id. And then in the resolver function, we also get this parameter. We return a pool object. Then for the mutation, we can create one that allows us to create a pool. So the document that we can send looks like this. Basically, it's like a function that accepts a question and a list of choices. And then we get back the pool object. And in Python, we look like something like this. We need to extend the graphene mutation, define the fields that this mutation is returning, and then the list of arguments. And then we need to create a mutate function that it's basically, if you use forms, it's like the save in a Django form, then it gets all the arguments, and then you can create the pool. So let's quickly test it. So I have this. Oh, it's not showing. Cool. Should be. So I already have an instance of Django running with this backend code. And so let's say I want to fetch just a list of pools with the question text. I can easily do like this. So basically, every time I need to do like an API call, I can just send the document that I need with the structure I need back, and I can fetch it like this. And if you want to get the choice set, I can just do something like this. And then I can get back the list of choices for this pool. There's also the ability to get like a single pool, as I showed you. Oops. So in this case, we are passing an argument with ID 1, and then we get the data for just that single pool. And if you want to create a new pool, we can use the mutation, create pool. Then I did a typo, so since everything is typed, the ID is telling me that there are some errors. So in this case, it's telling me that I probably meant choices. And when I run this mutation, it's basically going to create the pool on the backend, and it's also going to return that to me, which is quite nice. Also, like a quick demo I wanted to show you. There is support for Django channels. It's still not mature yet, but you basically can have a subscription like this in this case. So basically, every time a pool is updated, the number of votes is going to update in real time. So I have a vote mutation where basically I can just send a vote to this pool. So every time I click this, it's going to update in both pages. So on the left side, basically we get the response from the backend. But on the right side, we have a WebSocket connection running with Django channels that's receiving the updates in real time, which is quite handy. The only issue I find that's still not mature yet, but hopefully soon we're gonna have a nicer way to use Django channels with Graphene. But it can be done. So there's also integration with REST framework and with Django forms. So basically, you can reuse the forms that you have and the serializers that you have to create mutation. The problem is that this is still like I would say it's in beta. It's not. It works, but it doesn't have all the features that we need. And I'm gonna be working on this during the sprints if you wanna help and see how it actually works. So that's cool. This is it's really nice, at least from my opinion. Problem is, like, it's a new technology, especially in the Python world, and there are some things that we need to keep in mind, especially with security. One of the most asked questions on GitHub and on Stack Overflow is how to do authentication, and there are 3 ways to do authentication. One is to use Django session, and this works really well if you have an API that only works on your website, so you don't have any mobile applications. The other way is to use headers, like you do with a REST API, so sending like a token. And the last one is to use parameters. So since you can add arguments to all the fields that you have, you can, for example, send the token as an argument for a mutation. And this might work in some cases when you only have one mutation that needs authentication. So it's up to your requirements. So another thing is permission. So like if you've been used to Django REST framework, it's really easy to add permission to all the resources that you have. Unfortunately, there is no built-in features in Graphene yet. But something nice I really want to work on is having permissions on the field level. So for example, you can have an API where you have a user and the email it's only shown if the user is the current user or if a super user. And also you can have public and private fields, like you can hide fields to a certain user. Like GitHub is doing something like that, where they have a single GraphQL API that's being used also for like public access, but also private access. And they have some fields that are only available to the private API, but they only have one code base. Also, it's really easy to build malicious queries because we are giving loads of power to the front end. So you can build something like this, and imagine that this goes on and on. So you basically can do a query that takes a lot of time, and it's easy to someone to DOS your server, I guess. Some strategies to fix those issues, for example, could be having timeouts. So you could say if a query takes more than 1 second, you can discard it because 1 second is already too much for a user, and it might not terminate anyway. You can also do limits on the nesting, which basically says, oh, if the user is requesting a field that's, I don't know, 4 levels deep, I'm not going to do this query because it shouldn't be happening. They can also have query costs. Basically, you can add a score to each field and calculate the cost of query. So if you have nested fields, you can increment that cost based on the number of fields that you have. And this basically allows you to say, oh, I only want to run queries that are less expensive, I don't know, of 50, which is a made-up number. And you can also do static queries. It's something that there are few companies doing. I think Instagram is doing it. Basically, since they have control of the old pipeline, basically they can build a list of queries they're doing on their application, and basically save it on the backend either in the database or on files. And basically, the front end is going to send, instead of sending a JSON document, it's going to send an ID that corresponds to a query. And this allows you to also fix an issue that we have with caching, which is basically we are doing post request, and as you know, post request is not easy to cache, so you need to either do backend cache or client cache. So with that said, one of the reasons I want to give this talk is because I want to see more people using GraphQL in Python, and also want to see this library improve a lot, because it's nice, but it's not there yet. I think there is loads of room for improvement from this library. And also, I think GraphQL is an amazing, amazing technology, especially for like developers when you have to work with front-end people and people working on different clients. And also, it's good for the user because we are not wasting the user bandwidth. Imagine if you have like a lower-end phone, or if you have a connection that's really slow, you only send in the data that the client needs, and it should be performant. So I'm going to be at the sprints if you want to work on Graphene, and thank you.
So usually when you develop a library like that, you have like a problem that it solves. Can you kind of say in general what this solves?
Oh, yeah. So as I said, solves most of the issues that you might have with REST API. So basically, overfetching and underfetching of the data, and also writing documentation. In my experience, when I built GraphQL APIs, I didn't really have to write any documentation, because the people working on the front end, we just use the graphical IDE to fetch the information about the API. So I didn't really have to explain to them, this is the query that you need to do. And also, every time they had to do like a new screen on the application, I didn't have to build another endpoint, because basically they can change the response that can get sent to the front end.
And how does this look from the client side, from the JavaScript? How does you usually create these queries that are sent out?
Yeah. So there are different ways. You can go vanilla, so basically just sending an HTTP request with it's basically a JSON with the query. Or you can use there are a few frameworks. There is Apollo and Relay. Apollo is like the community one made by, I think now it's a company, but it's like all open source. And there's also Relay that's being made by Facebook. I use Apollo, and mainly because it works with different frameworks. So you can use it with React, Angular, Vue.js, and so on. But we can chat later if you want to have a look at how it works, because it's another talk. Thank you.